In this video, we're going to talk about a measuring device called galvanometer. Now, it is a sensitive instrument that we use to detect the presence of current in electric circuits. We also use it to determine the quantity of electricity. Now, this is because it is very sensitive and it measures very small quantity of electric current in a circuit. Now, a galvanometer can also be used to measure voltage across a circuit. But before that, you need to convert it into an ammeter. Okay, so let's look at the next subtopic. So let's say for us to convert it into an ammeter, let's say we have a little sketch. So let's say we have a resistance of a galvanometer here, and we connect a shunt. This resistance of the shunt. Let's call here point B and let's call here point A. Now, we need to connect a shunt in parallel. A shunt is a low resistance resistor. So we connect it to the galvanometer. Now, remember that according to Ohm's law, V is equal to IR. So here now, the voltage in the galvanometer, V subscript G, is equal to the current in the galvanometer times the resistance of the galvanometer. So, if we have that, we want to now measure across points A and B, the voltage is I, G, RG, plus that of the shunt, current in the shunt and resistance in the shunt. Okay, so for us to calculate the current that is in the shunt, it is given as the maximum current minus the current in the galvanometer. So you need to note that since the resistor of the galvanometer and the resistor of the shunt are in parallel, the voltage in them are the same. Now, an ammeter has a very low resistance and it is also connected in series with the circuit, so which means you have to break the circuit to insert the ammeter. Now let's look at this question. A galvanometer has a coil of resistance 5 ohm. So resistance of, for us to calculate it, resistance of that galvanometer is 5 ohm. So let's say solution. And gives a full scale deflection with a current of 10 milliampere. So it means that the current in that galvanometer is 10 milliampere. But we can't solve with this milliampere, so we have to convert to ampere, which is times 10 raised to power minus 2, which is 0.01. Converting, that is now in ampere. Okay, so it now says, how may it be made into an ammeter reading up to 10 ampere? So it means that we want to now, the shunt, which resistor, what will be the resistance that will be connected in terms of a shunt? That's what we are asked to calculate. That will make it read up to. So the current that in that shunt will now be 10 ampere. Okay, so because they are connected in parallel, the current that is in the shunt, that's V is equal to IR according to Ohm's law. The current in the IR in the shunt and the resistance of the shunt is equal to the current in the galvanometer and the resistance of the galvanometer. V is equal to IR. So the voltage in the shunt is also the same as the voltage in the galvanometer. Having this, we can make RS subject of the formula by saying it will be equal to IG RG over IS. If we plug in the values, we will have 0.01 times 5 over 10. If we press the calculator, we'll get 0.05 ohm. So what it means is that the galvanometer must be provided with the resistance, a shunt resistance of this, okay, such that 10 ampere passes through it and it is in parallel, and the current of 10 milliampere goes through that galvanometer and 10 ampere through the shunt. Okay, so let's look at conversion of a galvanometer into a voltmeter. Now a voltmeter is used to measure the potential difference between 2 points, and its terminal must be connected to these points. So if we have them point A and point B, so for us to measure the voltage or potential difference between that point A and B, we need to add a multiplier. A multiplier is a resistor that has very high resistance. So let's use Rm to denote a multiplier, resistance of that multiplier. Okay, so we connect it in series with the coil. So if we want to now calculate the VA, or let's say that Vm will be the highest voltage that can be measured. For us to calculate Vm, the highest voltage, it is equal to, you remember V is equal to IR. So the current in that galvanometer times the resistance in the galvanometer plus current in the galvanometer times resistance, the maximum resistance. Okay, so if we make the maximum resistance subject of a formula, we will have that it is equal to Vm over Ig minus Rg. Now, a voltmeter has very high resistance, you must know that, and it is also connected across points A and B, whose potential difference are to be measured. Now, we connect that in parallel to the device, or with the device that we are in concerned. So this question says, how can a galvanometer of coil resistance 20 ohm which gives a full-scale deflection when a current of 10 milliampere passes through it, be converted into a voltmeter reading up to 100 volts? Now, since it will read up to 100 volts, it means that the highest voltage it will have to read is 100 volts. Now, so because of that, it says that how can a galvanometer of coil resistance, so the resistance that is in the galvanometer is 20 ohm, which gives a full deflection of the current, which means the current that will have to be in that cell must be 10 milliampere. But we cannot use the milliampere, we convert it to ampere, which will give us which is 0.01. So because of that, the current that is in the cell will have to be 0.01 ampere. Now, having gotten that, because of this, we're going to use the equation that says that Rm is equal to Vm over Ig minus Rg. If we are to plug in these values, we'll have 100 over 0.01 minus 20. And if we press the calculator, this is here, we're going to get about 9980 ohm. That will be the resistance. So you can see it's a very high resistance. Now we have what we call a multi-range voltmeter, which uses a series of multipliers of different resistance, which can be chosen by, we use either a switch or plug and socket arrangement. Now also a multimeter is an instrument which can adapt in measuring current, voltage, and also resistance. Please do well to subscribe to my channel if you haven't. Thank you.